Welcome students. In this video we are going to see the relationship between coefficients of a polynomial and zeros. In the previous video we verified this result using an example. Now we will give the general proof. So we are considering a quadratic polynomial, and it is quadratic because the degree of the polynomial is 2 and whose coefficient a is not equal to 0. So for this to be a quadratic polynomial, what is the condition that we have to impose on the polynomial? The coefficient of x square, a is not equal to 0. So now what are we going to do is, as we have said in the previous example, ax square plus bx plus c, this can have at the most two factors which are linear and a constant factor, if at all it has any. So what do we do is, it can have two factors, namely x minus alpha and x minus beta, and if at all it has any constant factor, let us denote it by k, comma, you mention that k is a constant. You mention that k is a constant. Now what do we do is, you keep k as it is, you multiply this. So x times x, by using distributive law, x times x is x square, x times beta is minus beta x. Now minus alpha times x is minus alpha x, and minus times minus is plus, alpha times beta is alpha beta. Now what do we do is, you keep k as it is, this is x square, and you have x is common in both the cases. So you take alpha and beta out. So x, you pull out x and keep alpha and beta together. So alpha plus beta, right? So what do we do is, now you distribute k to every term. So this is kx square minus k times alpha plus beta times x plus k times alpha beta. K times alpha beta. This is nothing but ax square plus bx plus c. So we have represented this quadratic equation differently. So they happen to be one and the same, because this quadratic equation, if at all, has two roots maximum, at the most two roots, and at the most two zeros, and it can be factored into three factors, of which two is linear, one is constant. Okay. Now what do we do is, we equating coefficients of x square, x and constant terms. Let us see what do we get. Equating, comma, we get. What do we get? Let us see what do we get. When you equate the coefficient of x square, a must coincide with k. A must coincide with k. Okay, and when you equate the coefficient of x, on the left hand side the coefficient of x is b, so that is b, that is equal to, on the right hand side the coefficient of x is, of course we have to say along with the sign, together with the sign we have to say, so minus k times alpha plus beta, and finally on the left hand side the constant term is c, so constant term is c, and on the right hand side the constant term which is independent of x is what is called constant. There is no x involved here, so it is constant. So this is k times alpha beta. Okay, but what is k? K is a, so you can replace this by a. This is minus a times alpha plus beta, and here also a times alpha plus beta. Okay, so from here, what is alpha beta? Alpha plus beta is nothing but minus b by, division by a is allowed because a is not equal to 0. Because a is not equal to 0, so division by a is allowed. So minus b by a. Okay, and from here alpha beta is equal to c by a. and alpha sum of, now What are alpha and beta? We can write here where alpha and beta are zeros of p of x, zeros of p of x. Zeros of p of x, right? Alpha and beta are zeros of p of x, because if this is a quadratic polynomial, it can have at the most two zeros, namely alpha and beta. Now what is here? What is alpha and beta? So sum of the zeros. So from this you call this as 1 and you call this as 2. So from 1 and 2, from 1 and 2, sum of the zeros, which is alpha plus beta, that is equal to minus b by a. So this is the formula, and the product of zeros, which is alpha beta, is c by a, So this is the formula, this is the relationship between zeros and coefficients, b by a, c by a. Okay, this is the relationship between zeros and coefficients.